This video is about comparing sample means using t-test and ANOVA. In this video, I will discuss these topics: one sample t-test, two sample t-test, pair t-test, one-way and two-way ANOVA. In this hypothetical example, the Federal Trade Commission is investigating the weight of coffee cans. A company makes millions of coffee cans. The label claims the weight to be 3 pounds, but some consumer groups believe it's actually less than 3 pounds. You want to investigate this matter. You collected a sample to investigate whether the average weight of the coffee cans matches the claim on the label or not. Before diving into t-test and ANOVA, I will discuss some of the terms that are used. The first one is the difference between sample and population. A population is the entire set of individuals or items of interest. In this example, the millions of cans of coffee made by the company is the population. It's not possible for you to check the weight of millions of cans of coffee, and therefore you take a sample. A sample is a subset of a population. So for example, you may decide to pick up 36 cans of coffee from a retail store. So that 36 cans of coffee that you have picked up for investigation purpose is the sample. Millions of cans of coffee that the company has made is the population. We take a sample because it is not possible to test the entire population of coffee cans. It will be very expensive. The next question is that why hypothesis testing matters. Given that we may have mean, median, quartiles, standard deviation, variance, and other statistical tests, then why do we do hypothesis testing? We do hypothesis testing because we want to make inference about the broader population. Now in this case, we have collected a sample. For example, our sample comprises 36 cans of coffee. Based on that small sample, we want to make an inference about the broader population. We want to see what's our probability that whatever we are getting from the sample that also applies to the population. And for this purpose, we do hypothesis testing. I have explained all these things in another video in great detail. For this purpose, we develop hypothesis. And we make two types of hypothesis: null hypothesis and alternative hypothesis. So when formulating these hypotheses, we have two approaches. One is status quo. The status quo approach, for example, in this case would be that FTC believes that whatever company is doing, they are doing it fine. The weight of coffee cans will be 3 pounds, and alternative hypothesis would be exactly the opposite of null hypothesis. In the reverse process, you start with alternative hypothesis. You start with what you are looking for. For example, in this case, what FTC is looking for, and then you move on to null hypothesis. We will be doing all these tests in Microsoft Excel, and Microsoft Excel will give us p-value, and if p-value is less than 5%, then we will reject null hypothesis. So the very first one is one sample t-test. In one sample t-test, we have only one sample, and we want to compare its mean to a known or hypothesized population mean. For example, if FTC is investigating the weight of coffee cans and the label claims the weight is 3 pounds, but some consumer believe that it's actually less than 3 pounds, you collected a sample to investigate whether the average weight of coffee cans matches the claim. So you want to compare two things: the weight of coffee cans mentioned on the label, which is 3 pounds, and actual weight of coffee cans obtained from lab testing. And for this purpose, we'll be conducting one sample t-test. This is our data in Microsoft Excel, and we start with hypothesis formulation. So for hypothesis formulation, we can have two approaches. One approach is status quo approach, and other is reverse path approach. So status quo approach is that null hypothesis would be that the mean of coffee cans weight is 3 pounds, and alternative hypothesis would be exactly the opposite. So if null hypothesis is that mean is equal to 3, alternative hypothesis would be that it is not equal to 3. So the other approach is to use reverse path, whereby we start with alternative hypothesis. So in alternative hypothesis, we start with what FTC is looking for. They want to conduct an investigation, and they are looking for if the mean is less than 3. So we start with alternative hypothesis, and then we move to null hypothesis. In this case, if our alternative hypothesis is that mean is less than 3, null hypothesis will be exactly the opposite, which means null hypothesis is that mean is equal to 3 or greater than 3. And When we will be doing it in Microsoft Excel will give us values of averages and p-value, and if p-value is less than 5%, we will reject null hypothesis. So let's start one sample t-test. The first one is sample size 36. We can also do it like this way, count, and then standard deviation. For standard deviation, we'll be using this formula, sample. So this is the formula I use, standard deviation dot s, which means sample, and then I selected all the cells containing data, and standard deviation turns out to be 0.170. The next one is standard error, and for standard error is equal to standard deviation divided by square root of sample size, and that gives us 0.028. The next one is average, and that turns out to be 2.290. Hypothesized mean is 3, which is the weight mentioned on the label. The next one is t-test, and for t-test we'll be using this formula, which means mean minus hypothesized mean divided by standard error, and that gives us t-test value, that's -2.824. Then the next thing is degree of freedom, which means the sample size minus 1 is 35. The next one is p-value. And for p-value, we'll be using this formula, which means t distribution, and then t-test, and then degree of freedom, and then cumulative true. So this is t-test value. This pop-up suggests that the next thing is degree of freedom, and degree of freedom is 35, and then it says cumulative. Yes, so I will write here true. So p-value turns out to be 0.004, and the other one p-value will be 1 minus 0.004, and that would be 0.996, and p-value two-tailed will be 2 multiplied by minimum of these two, 0.004 and 0.996, and that will give us 0.008. Now in these results there are many things, but the most important things are the ones that are highlighted in blue color. This average, that's 2.920. This average is less than hypothesized mean. So the weight that's mentioned on the labels is 3 pounds, but this average turns out to be less than that. And the second thing is this p-value is less than 5%, because we had already decided that if p-value turns out to be less than 5%, we will reject null. Mean is equal to or greater than 3, we reject that. And it means that these results are unlikely to have occurred by chance, and that there is a significant effect. In other words, it means based on the findings of this analysis, FTC can initiate an investigation against the coffee maker company. The next topic is two-sample t-test. In two-sample t-test, we will have two independent samples, and we want to compare their means. We want to know if they are different or not. So here's an example. A researcher wants to compare the average test scores of students from two different schools. Now these are two different schools, which mean they have different teachers, different systems, different pedagogies, different facilities. They are entirely different. And we want to see if there's a significant difference in their performance or not. Or another example would be that a company is conducting training program, and they have two types of training programs, and they want to compare the efficacy of these two training programs. So that will be two sample t-test. Now here is our data. And in this data, this is the score of participants who underwent training in program A, and this is the score of participants from program B. And we want to determine if these two scores are different or not. For this purpose, we start with hypothesis formulation. One way to formulate hypothesis is that null hypothesis, there is no difference in the means of two samples. So in this case, our null hypothesis would be that mean of program A is equal to mean of the score from program B. And alternative hypothesis would be exactly the opposite, which means mean of participants from program A is not equal to mean of participants from program B. So that's a status quo approach, which assumes that there are no much differences. The second approach is if program administrators believe that one program is better. So for example, as you can see here, it looks like we have higher values over here compared to this one. Suppose if administrators believe that program A is more efficient than program B, then in that case we start with alternative hypothesis. The mean of scores from program A is greater than mean from program B, And then we move to null hypothesis, and null hypothesis would be exactly the opposite. Mean of program A is less than or equal to mean from program B. Now for this purpose, we'll be conducting two sample t-test because we know we have two independent samples. Click on data and then click on data analysis, and then in data analysis go to t-test. So here you see t-test two sample assuming equal variance. Click on OK. Now the first one is variable 1 range. I will select this whole column, and then variable in second range, I will select this whole column, and then click on labels because labels are included in my selection. Alpha is 5%, and output range, I want my results to appear here. And if I click OK, it gives me these results. Now there are many things that are important, but the most important things are these. The first one is mean, and the second one is this p-value. The mean of program A is 85.9 and the mean of program B is 79.65, which means the mean of program A is higher than the mean of program B. And second thing is that our p-value is very small. We had decided that if the p-value is less than 5%, it would be rejected. This is scientific notation. I can convert it into numbers. So for that purpose, I will click numbers, and as you can see, it's very small. Now this means that we have to reject our null hypothesis. In any case, either this case or this case, it will be rejected. When we synthesize information from mean values and from p-values, we conclude that first of all, mean of program A is higher than the mean of program B. And second thing is that because p-value is very low, we can conclude that this effect is likely to be observed in the broader population as well. These results are unlikely to have occurred by chance. The next one is paired t-test. In this test, we compare the means of two related groups. So there is basically just one sample, but that one sample has undergone some treatment and we want to compare it before and after treatment. So for example, pharmaceutical companies use this test if they want to determine the efficacy of a drug. They would administer that medicine to the patient and then they would see what happens. The test is used when the samples are not independent but are instead paired in some meaningful way. This often occurs in before and after scenario. For example, a fitness instructor wants to evaluate the effectiveness of a new workout program. The instructor measures the weights of 10 participants before and after the 8-week program. Now, in this case, the sample remains the same. The fitness instructor would be measuring the weight of each person before and after that program. Here is one example. Here is the data about a sample before and after a particular treatment. So there is some material that has undergone some treatment which increases its strength, and your objective is to determine if the treatment makes a difference. So because we know it's the same sample just before and after, so we'll be using paired t-test. So this is our status quo approach, and null hypothesis is that difference in the means of before and after is 0, and alternative hypothesis would be exactly the opposite, which means the difference in the mean is not equal to 0. So I will be conducting paired t-test, and Microsoft Excel has this feature. Click on data and then data analysis, paired two samples for mean. Click on OK. And the first one is I will select before column and then I will select after column. Click on labels because labels are selected in our selection. Alpha is 5%. Output range, I want my results to appear here. Click on OK, and here we have our results. In these results we have many things, but the most important things are mean and p-value, and our hypothesized mean difference is 0. Before, mean was 0.002, but the mean of after treatment is 0.99. There's a significant difference between them. And second thing is our p-value, 0.028, which is less than 5%, so which means our null hypothesis would be rejected. This is null hypothesis which says that the difference in the mean of 2 is 0. So therefore, we will have to reject this null hypothesis. When we synthesize this information from the mean and from p-value, we conclude that first of all, there's a difference. We can say that the strength of material improves after treatment, and we can see it's 0.99, which is significantly greater than 0.002. And second thing is that p-value is less than 5%, which means although we have a small sample here, but we can observe the same effect in the broader population as well. And we can also say that these results, they are unlikely to have occurred by chance and that there is a real effect. The next one is ANOVA. ANOVA, or analysis of variance, is a statistical method used to compare the means of 3 or more independent groups. Now that is the distinguishing feature. In t-test, we had 2 groups, but in this case we have 3 or more independent groups, and we want to see if there are differences in their mean or not. An example is a researcher wants to compare the effectiveness of 3 different teaching methods on student performance. Now here are 2 keywords in this problem. First thing is 3, and that's the reason we are using ANOVA. And second thing is that you want to measure if there are differences in the mean performance of these 3. Here's an example. An automobile company buys material from 4 different suppliers. The strength of the material from each supplier is provided. So we have the strength of material from supplier 1, 2, 3 and 4. Find out if there are significant differences in the material strength among the 4 suppliers. Our null hypothesis would be that all the population means are equal, which means the status quo approach, there is not any difference in the mean strength of material from different suppliers. And alternative hypothesis would be exactly the opposite of this one, which means at least one group mean is different from the other. Microsoft Excel has a feature whereby it provides ANOVA. Click on data and then data analysis, and then we go to ANOVA. In ANOVA, we have a single factor because it's about material strength from suppliers. So that will be a single factor. Click on OK, and then input approach. And for input approach, I will select this one. Labels in first row, because as you can see, labels have been selected. Alpha is 5% and output range, I want my results to appear here. And if I click on OK, it shows us this one. There's a lot of information here, but let's highlight the most important one: average mean and probability value. The mean of supplier 1 is 11, and for supplier 2 is 8.9, 10.68 and 8.8. And the second thing is that p-value is less than 5%, it's 0.03. Now when we synthesize information, it shows that first of all, the strength of material is different. And second thing is that because p-value is low, it means although here we have limited data from 4 suppliers, only 10 samples, as you can see, these are 10 samples from each supplier, but we can expect that these results will also hold in the broader population, which means we are confident that the same phenomena will also be observed in the broader population, or these results are unlikely to have occurred just by chance. And the last one is two-way ANOVA. In two-way ANOVA, we want to analyze the influence of 2 categorical independent variables, which are also called as factors, on a continuous dependent variable. So for example, a gardener wants to study the effect of 2 factors, fertilizer type and water amount, and they will be called as factors. And we want to study the effect of these 2 factors on plant growth, which will be dependent variable and it will be a quantitative variable. For example, it could be height of plant, that will be continuous variable. Another example is that you want to assess the impact of gender and program measure on annual income. Now over here we have 3 variables. One is gender, which is a categorical variable, and then we have program measure in college, and then annual income, which is a continuous variable. The continuous dependent variable is annual income, while the 2 categorical factors are gender and major, with the major being mathematics, sociology and public administration. Determine if there are significant differences in annual income based on gender and major, as well as any interaction effect between these factors. Now this is our data. When you are doing two-way ANOVA in Microsoft Excel requires this data to be provided in a specific format. All these categorical variables are in the first column: gender, male, female, and here program measures like math, sociology, and public administration. And the data about dependent variable, which is continuous variable, is here. This format is essentially required when doing two-way ANOVA in Microsoft Excel. We start with formulating hypothesis, and our null hypothesis is that there are no significant differences in the annual income among genders. So the first one is about genders. The second one is that there are no significant differences in the annual income among the major program measures. And the third one is that there is no interaction effect between gender and major on annual income. So the first hypothesis, null hypothesis, is about effect of gender on annual income. The second null hypothesis is about the effect of major on annual income, and the third is about interaction between gender and major and their effect on annual income. Microsoft Excel has this feature, so click on data and then data analysis, and then here we have ANOVA two-factor with replication. So the first one is input range. I will select the whole data, and the next thing is rows per sample. In this case we have 20 rows. Our data has been organized in a way that there are 20 rows for male and 20 rows for female. So rows per sample is 20, alpha is 5%, output range, I want my results to appear here. Click on OK. Here we have a lot of information. Let's highlight the most important one. These results show the average salaries of male for math is 81,247, for sociology it's 60,034, for public administration it's 75,513, and the total is 72,265. The average salary for females in math is 75,289, which is less than 81,247 for male. The average salary of female in sociology is 55,191, which is less than 60,034 for male, and the average salary of females in public administration is 70,345, which is less than 75,513 for male. So one thing we can see, the average salary of females is lower across all programs. Second information is that when it comes to total, the average salary in math is 78,268, for sociology it's 57,613, and for public administration it's 72,929. We can also compare the salaries of male and female against this average. So for example, in case while the average in math is 78,268, the average of females is 75,289. The overall average in sociology is 57,613, but for females it's less, 55,191. Overall average in public administration is 72,929, but for females it's only 70,345. So that's one piece of information which shows that in general female are earning less across all measures. And the next thing is p-value. So in the p-value, the first one is sample, which means gender. The p-value is very small, 10 raised to power negative 13, and I can convert it into numbers. So these are very small. This means we can reject our first null hypothesis, which said that there are no significant differences in annual income among the gender. So we reject this null hypothesis. And second thing is that this is about column and program. This is less than 5%. We are also going to reject this null hypothesis, which says there are no significant differences in annual incomes among the major. And the last one was about interaction. And the interaction, the value of interaction, this is more than 5%. So which means we cannot reject this third null hypothesis, and we would say that interaction effect is not significant. Now when we synthesize information from these averages and p-value, it is clear that on average female are making less compared to males and also compared to averages. And because p-values in these two cases, which mean based on gender and based on program, p-value is less than 5%, we are confident that the results that we see over here, we can also see in the broader population. Over here, we have very limited data, but based on these p-values, we are confident that this phenomena will also be observed in the broader population, and that these results are unlikely to have occurred by chance, and that there is a real effect.